Hello everyone, and welcome to the second part of the demonstration for the leaded steel bushings project for machining 220 at Laney College. Today we're going to be performing all of the roughing operations on the steel bushing, and then in part 3, the final part, we'll get to actually finishing it. So we'll get all the way through steps 2 through 10. So step 1 you should have already done, cutting your material to the proper size on the bandsaw. And then step 2 is setting it up in the four-jaw chuck, the principle behind which we went over in the last part of the demonstration. And then we're going to go all the way through to rough boring out the inside diameter of the bushings. All right, that's a natural place to stop because that's actually the sort of point of no return, the last chance to break down the setup before re-indicating the part into the four-jaw chuck would be extremely difficult to do. In the advanced classes in the machine technology course progression, like 220 and 230, we do a lot less hand-holding. We progressively hold your hand less and less through the process. Okay, so in 210, when I went through all of these projects, I did it in such a way that you could see every single part of the process. I explained every last little detail, and I'm not going to give you nearly as much information here. All right, I will go in depth into new things that I think are worth talking about that we haven't seen before, but for the most part, I'm going to go through the process, and I'm not going to show you things like setting tool heights, because that's something that you should already know how to do. Okay, here's the print for the part that we're going to make. We went over this in the lecture video, so I'm not going to go over it really in any more depth, okay? But we should have this to reference while we're machining. Okay, here's the stock material, and the first step is to get this indicated in the four-jaw chuck. So just like last time, we're going to stick it in the four-jaw chuck. I've already gotten this pretty close just by referencing the chuck jaws off of the concentric rings on the face of the chuck. We're going to have about 2 1/4 of an inch of stick out according to the project planning worksheet, so that's about right there. Go ahead and snug this up just so that it's not all loose in there. Go ahead and put the dial indicator up on this surface, something like that right there. Perfect. Okay, let's see what we are. So that's about minus 16 or so, and then 90 degrees we've got about minus 30. Okay, so I'm going to go ahead and tighten it right here. Okay, now we're about minus 10, so I'm going to loosen this side a little bit. See what the other side is. Okay, pretty close. Okay, let's check 90 degrees now. 0, minus 14. Okay, so I'm going to back this off a little bit. Zero that and check it. Minus 3. Okay, so I'm going to tighten it over here. See what that is? 0, 0, 0, 0. Okay, great. So I'm going to tighten it all the way around just so I know that we're equally tight everywhere. Because remember, what we're trying to do is not just align the part, we're also trying to simultaneously get it to be rigidly clamped in the chuck jaws. So that looks good to me. Okay, the next step is getting all of the tool heights adjusted and getting all the tools square to the machine, which I've already gone and done. But I want to talk a little bit about things to watch out for with these carbide inserts here. So one thing is that you really want to make sure that the edges that you're using on the insert are good, okay? So like this is the one that was on there just a moment ago. Okay, and that one is definitely blown out. Okay, it looks like it's been fractured. Okay, and it looks like it has a little bit of plastic deformation. It like got sort of wiped off. So this side is no longer good, okay? But this other side here, it's got some discoloration, but it doesn't have, well, no, actually that's not true. It's got a little bit of rounded off edge on it. Okay, but on the other side of the insert, remember with these negative inserts, we can actually use both sides of the insert. So we get 1, 2, 3, 4 cutting edges, okay? On this side right there, actually that looks okay. This side looks even better. And they're not perfect, but for roughing, they're going to be okay. They don't need to be perfect. These negative geometry inserts are not very sharp to begin with, and when we're roughing with them, we're really not concerned with things like surface finish or anything like that. We're just trying to remove material as fast as we possibly can, and we're looking for things like chip control. We don't want to produce too much of a ragged edge on the lead of the cut. We don't want to dump too much heat into the part or anything like that, okay? Or excessive power consumption because we're trying to bludgeon material off with too dull of a tool. Those are the kinds of things that we're worried about here, okay? But this is going to be just fine. When we get to the finishing operations, then we're going to need a very, very sharp tool. But this is fine for now. Another thing to watch out for when you're removing inserts and replacing them or indexing them is that the inserts and the seats, okay, the seats in there need to be really clean, all right? You don't want to clamp the insert down on dirt, okay? I mean, just, that goes for everything, right? Don't clamp things down on chips and dirt, right? I should also mention that this little seat right here looks an awful lot like an insert. And it's actually made out of tungsten carbide, but it's not a cutting tool, right? So don't try to cut with the seat here. So an easy way to clean this off is just to get a little bit of like canned air, okay, and blow it out. And that works pretty well. Okay, go ahead and replace the insert. And then tighten it down with the proper Torx wrench, okay? Proper style of wrench and the proper size to fit right there in that special star-shaped fastener. And there you go. Tighten everything down. And we're ready to cut. So step number 3, the first machining operation, is going to be facing the end of the part just to clean it up and get rid of that bandsaw cut. So a big part of what I'm going to be showing you in this part of the demonstration, where we do the roughing machining operations, is just a general approach and some tips and tricks to maximum material removal rate. Okay? At this stage of the game, we're just looking to rip material off of the part and get it to its basic size, but we're going to leave a little bit of material over on everything, right? And so what we're looking for right now is not precision, but rather speed, productivity. Okay? And a lot of that comes from just making the minimal number of movements or not using excessive levels of precision when it's not required. So you'll see that in the demonstration. Okay, going to go ahead and turn this on. Okay, going to come over here with my tool and just touch the end of the part just like that. Back the tool off a little bit. And I'm not even going to use an indicator to tell me how far I'm going to travel to the left. I'm just going to travel enough so that I can clean up that surface. For a roughing cut on this tool, I'm going to go 9 thousandths per revolution. L, C, R, 2, and W. Adjust the crossfeed for a cut. Here we go. All right, when we get past center, pull it off. It looks like I cleaned up all the way to the center there, so that's good. Okay, the next step is to rough the OD to 1 inch 470 thousandths, okay, and back about 2 inches, okay. That 2 inches is not a precision distance, okay. We just need to machine far enough back so that it cleans up enough so that when we go in and we part it off, we're not going to have like a little piece of stock material on the end of the part. So this is 1.5 inch stock, but let me double check that with the caliper. Yeah, 1.5 inches. So I'm going to touch off and take 30 thousandths. As for that 2-inch distance, I'm just going to give myself a little bit of a visual indication of where that is based on the end of the part with a ruler. Okay, so set the ruler up to 2 inches and then just make a little Sharpie mark. It's going to be a little bit easier to see this if the Sharpie mark is all the way around the part on the circumference. So I'm going to go ahead and turn this on very, very slowly. And just line the Sharpie up with that mark that I already made. Yep, and make a full ring like that. Just double check that that's 2 inches right there. Yep. So right in the middle of the Sharpie mark is where the 2-inch mark is. Okay, let's go. I'm going to come in and touch off. Set my 0 on my cross slide, go in 30 thousandths, set up for a cut, still at 9 thousandths per revolution for the feed rate, and here we go. Right there. Okay, pull it back to the beginning again, back into my number. So the next step is to mark another line at 1 1/8 inches back from the end of the part. So exactly like what we just did, but 1 1/8 of an inch. And then we're going to cut the 1 inch 210 thousandths diameter on the front of the part back to that line that we just made. So 1 1/8 inches is right there. We can adjust where that shoulder is later on, right? Because we can either face a little bit off the end, or we can move where that shoulder is by touching off on the shoulder, moving over a specific amount, and then plunging in, okay? So there's no point in wasting time with delicate indicator work at this roughing stage, okay? Adjust it to a very slow speed. Line up the Sharpie. Make a mark. Okay, so it looks like 1 1/8 inches is like right at the start of the Sharpie mark, so that's where I'm going to cut back to. All right, let's see what the dial caliper says for this measurement right now. Yeah, so right there at 1 inch 470. So we're going from 1 inch 470 down to 1 inch 210, 260 thousandths. And I'm just going to take that all in one go. That's why they call me One Cut Man. Okay, so that's 100, 260 right there. Engage. Right there. Pull back on the tool to clean up that shoulder, and that's it. Remove the tool. The next step is to rough out the hole in the center of the part. And the first thing we've got to do is take a center drill and put a little spot on the end of the part to help guide our other drills. So drill chuck goes into the tailstock, just like that. Number 4 center drill. Okay, tighten the tailstock down. Give it a little bit of coolant. And there we go. Actually, we only really need to go that deep just to give it a little spot. So we don't even need to go down on the cone of the center drill. We're just using the center drill to spot a hole. We're not actually trying to make a center because we're not going to run this part between centers, right? Okay, back this off. Okay, time for the 1/4 inch drill. Make sure that the drills you use are sharp. Okay, now this one is definitely chewed up on its cutting edges, all right? It is really dull, definitely worn. So something of this size we can very easily sharpen in our drill sharpener, okay? The bigger sizes we have to sharpen by hand. So we don't really expect you to do that at this stage of the game. You can ask your instructor to sharpen one for you, but this one is pretty easy to do. So let me go do it. Okay, there it is. That only took about 30 seconds to do. Much, much, much nicer. Okay, this is going to cut a lot better and a lot straighter. Okay, so really no excuse to use a dull drill in here. Okay, here we go. Okay, to show you how we're going to get that 2-inch depth on the hole, I'm going to have to extend the quill. So you can see over here on the top of the quill that there are actually some ruler divisions in both inches and millimeters. Okay, so I'm going to actually extend the quill so that the 1-inch mark lines up with the end of the tailstock. And the reason I start off at the 1-inch mark is because I can't fully retract it all the way to the 0 without popping the drill chuck out of the quill taper. Okay, so I'm going to go ahead and lock the quill down right there. Then I'm going to bump the drill up against the end of the part, just like that, and then I'm going to lock the tailstock down, unlock the quill, and now all I have to do is drill to not the 2-inch mark, but the 3-inch mark. Okay, so going 2 inches from where I am right now at the 1. Okay, I'm going to give it some coolant. All right. This is a pretty deep hole, so we're going to have to do what's called peck drilling, right? Where every now and then we'll stop feeding in order to break the chips, but we'll also pull back out from time to time to introduce more coolant into the bottom of the hole. Whoop. And see, that's what happens if you don't peck right there. Okay? So what I need to do is make sure that the drill chuck is nice and tight, and I need to peck more frequently. That's called spinning a drill. That's not what you want to do. You can really feel it when it starts getting packed up with chips. Like there, it's totally packed up with chips. If the chips have nowhere to go, then yeah, that's when your drill is going to grab and start spinning. Okay, right there is 2 inches. Okay, loosen the tailstock, clear the rest of those chips off the drill, remove the drill, remove the drill chuck by backing off on the handle, on the quill for the tailstock. Okay, the next step is to go in with the 13/16 drill, also to 2 inches deep. As you can see, the 13/16 drill does not have a straight shank on it, a cylindrical shank. It has a taper on it. Actually, it's a Morse taper. And so we could put this directly into the tailstock without a drill chuck, except that the taper is too small. So we're actually going to use this taper adapter. So this has a number 3 Morse taper in the center. This is a number 3 Morse taper. And it steps it up to a number 4 Morse taper on the outside, which is what the tailstock takes. You got to make sure that these are really nice and clean. Again, like any tapered surface, it's got to be really clean. Okay, so those go together, all right? And then that goes into the tailstock. And again, we're going to move this out to the 1-inch mark as a starting reference. So like right there, okay? And then seat the tapers like so. Bump this whole shebang up against the end of the part. That looks good. Lock the tailstock down and unlock the quill. All right. Okay, same idea here, 2 inches deep. We're gonna peck drill. Now, because this drill is so much larger, okay, the flutes are much, much bigger. And so chip evacuation is not as much of an issue. All right, right there. Okay, turn the spindle off, clean off the drill, back the tailstock off, back the quill out to pop off the drill like so. Now, don't just go putting this back into the cabinets like this with the taper adapter still on, okay? Remove the taper adapter. There's a separate drawer for this and a separate drawer for the drills. So these can't actually really be separated by hand. You really need to coax them apart mechanically, all right? So back in here, we can actually put what's called a drift into this little slot in the back. And if we drive that drift, it's just a wedge, right? If we drive the drift into the slot, then it'll pop out the back of the drill on the tang, and that'll remove the two components from one another, okay? Now this one, you just hit it with a hammer, but we also have a different style, this kind of Buffy the Vampire Slayer looking mechanism right here that has a built-in slide hammer, so it's really easy to separate. Just like that, okay? All right, folks, at this point, the part is done being roughed, okay? We've got our hole pre-drilled. We've got these diameters turned to the lengths that they're supposed to be, you know, within reason, right? So there's extra material on everything. So this gets at two big machining strategies, okay? The first one is rough everything before you finish anything, okay? So just like on the angle plate project, when we start removing large amounts of material, then the stresses in the material start to relieve, okay? So we don't go finishing anything until we've roughed out everything, right? So for the most part, all of the features are the basic shape that they're going to end up being, but there's still a little bit of meat on them so that we can finish them. So if you were to go and finish the outside diameters to their proper lengths, and then you went and drilled out and bored the hole here, well, this wall thickness is actually pretty thin, okay? So you run a very, very high risk of, after you machine all this stuff in the middle, now you've distorted this outside diameter, or what could happen is that you, just because of the force of the drill, you've knocked this out a little bit from where it is in the four-jaw chuck, okay? So remember that significant cutting forces can also push the part around in the fixture. The second machining strategy here is rough the outside, then rough the inside, then finish the inside and finish the outside. This sequence, whenever it's possible to do it, will give you the most consistent results. So I know that on your project planning worksheet it says that step number 10 is to rough bore the inside diameter to 845 and 2 inches deep, and that's the last chance for you to break down the setup, okay? And I know that I said at the beginning of this that we were going to go through step 10, but actually this is already considered roughed out. So we could take a few cuts on the inside diameter here just to clean up that drilled surface, but we don't need to. And the point of this is just saying that once you've roughed this down so that you've got about 30 thousandths of material left, that is the last time when you can safely break down your setup without having to go through all that complicated rigmarole of re-indicating this in 2 spots or 1 spot plus a diameter in order to re-indicate to finished diameters, okay? If we leave ourselves enough material on here to begin with, right, then we don't have to do anything more than just putting an indicator on it, getting it within 1/1000th of an inch, because we still have material to come off of every single surface, so everything's going to true up really nice and easy. right? So those delicate run-out controls for the inside diameter and the outside diameter, and the perpendicularity of this flat shoulder to the outside diameter, those will all be easy to achieve because we did it in the same setup. But if you go finishing diameters and then take this out and put it back in the next time you walk in, well, unless you indicate that inside diameter perfectly, all of the surfaces that you cut from that point on will not be concentric to the surfaces that you've already finished. So that's why that note is there, okay? You can bore out the inside diameter a little bit, okay? But you have to leave a little bit of material on there, otherwise you're going to run into a lot of trouble. So at this point, we could continue on, if we've got enough time left in the day, and finish up this part and then part it off. Then we could loosen the chuck, stick the stock material out another 2 1/4 inch, and then do another one, right? Remember that there are 2 of these that we need to make, and they differ by that inside diameter. But if you're running low on time at the end of the day, then what you can do is just take this material, leave the roughed out part on the end of it, and just flip it around 180 degrees and work on the other side of the stock material. And then you can get this far on the other part. So it's going to change our strategy a little bit. We're not just going to machine a part, part it off, stick the part out a little bit more, and then do it again. Now we're going to rough out 2 sides and then finish 2 sides, okay? But this is relatively easy to do, and it's very low risk. So if you have a little bit of time left in the day, just go ahead and do what we just did, but on the other side of the part. In the next part of this demonstration, part 3, the final part, we'll go through and do all of the finishing operations on the part. But that's the next video. So see you then.